Oh, and don't forget, if you have circuit training from last weekend, you can put it in the tray. The new one is over on the table there like normal. Okay, so on Friday, we talked about inverses, how when you see an inverse trig function, you are solving for the angle that will give you that trigonometric value. So it's like inverse sine, negative rad 3 over 2. So I know what angle will give me a sine, negative rad 3 over 2. And remember, the biggest thing we want to remember is what quadrants those functions are defined in. So that way we only get one answer. So the last one we did on Friday was this guy, where we can evaluate it, but it's not on our unit circle, negative 1/3. So first we figured out what quadrant it was in, we drew the picture, and then the triangle can help us evaluate the expression. And then you can always check it in your calculator. So this problem has an X in it, but it's the same sort of setup, okay? On the inside, we have an inverse sine, which remember, that will evaluate to some angle theta. 3x over 5 is not on our unit circle, so we need to be able to draw where theta is located. Do you remember from Friday what two quadrants inverse sine is defined in? One and, what did you say? Not two. 1 and 4 is inverse sine. Yep. So,
wait, inverse sine?
Sine?
Oh, I've seen. I was looking at.
Oh, cotangent is going to be 1 and 2. Yeah. Yep. No. Okay. 1 and 4. Now, here's the thing. Because we don't know what x is, we don't know if what's inside that fraction is a positive or a negative number. So that's why they gave us this. We know x is a positive number, right? Between 0 and 5/3. And if you plug in 5/3 to that, you'll get inverse sine of 1, which isn't super important. But the fact that it's positive tells me that the sign is positive. So therefore, I am in quadrant 1, okay? So there's my right triangle. Remember, your right angle is always on the x-axis. Your theta is always next to the origin. Sine is what two sides of our triangles? Opposite over hypotenuse. So opposite is 3x. Hypotenuse is 5. And now we use the Pythagorean theorem to find the missing side. So 3x, hope I want to do that in a different color, hold on. 3x will be squared plus, I'll just call that side y that I'm solving for, squared equals 5 squared. So y squared equals 5 squared is 25 minus, if you do 3x squared, because it's a product there, you can distribute the squared in. So it's going to be 9x squared that I'm subtracting. And then last but not least, we take the square root. The square root here could be a plus or minus, but because I'm in quadrant 1, the triangle will tell you whether that should be positive or negative. In this case, it's going to be a positive number outside that square root, okay? All right, so I have all three sides. It's a little gross, but I have all three sides. So now if I go back to my original problem, y equals cotangent, and then I'm going to replace that inverse sine 3x over 5 with just theta, because that's what we drew, theta. And now you need to find the cotangent of theta with this triangle. So how do you find cotangent? What two sides? Its tangent is opposite over adjacent, so cotangent is adjacent over opposite. So my adjacent side is this gross guy, and my opposite side is 3x. That doesn't reduce because one's inside a square root and the other is not. It's gross, but that's our final answer. Okay, so same procedure as Friday. There's just an x in there now, so we can't simplify as much as we'd like to. All right. Any questions on that? All right, last two problems you need a calculator for if you want to grab those. Okay, so when we solved for all the things in right triangles, we didn't actually solve for angles because we hadn't done inverse functions yet. But you have probably done that in a previous math class, so that's what this problem's talking about, how we can use an inverse function to solve for an angle that's missing in a right triangle. Okay, so it says a security camera is to be installed 20 feet away from the center of a jewelry counter, and they drew the picture nicely here for us. The counter is 30 feet long. What angle to the nearest degree should the camera rotate so that it scans the entire counter? So if you guys want, you can draw this picture in your notes. You've actually got two congruent, because the camera's in the center, right triangles back to back here. Okay, so the height there is 20. The length across both triangles is 30, but one's 15, so you could also label the other as 15, and then that 20 is a shared side. We want to find theta, and theta covers both triangles. So what I would do instead is, if I just, for example, look at the left triangle, I would solve for the angle inside that first. You can give it a different name. I'll call it alpha. Okay, it looks like a little fish. And I would solve for alpha first, and I know alpha would be the same in both of my triangles. So all I have to do is double it then at the end to get my theta that I'm missing. Okay, so looking at the triangle on the left, if alpha is my angle of reference, how are 15 and 20 related to it? Opposite, adjacent, hypotenuse. What are they? 15 is opposite, and 20 is adjacent. So these are just SOHCAHTOA questions. The only difference now is we're not missing a side, we're missing the angle. If I have opposite and adjacent, which trig function am I using to solve? Tangent. Tangent of alpha is opposite over adjacent. Now, to do these problems, because we want an answer in degrees, your calculator needs to be in degrees. So double check it is, because I know we flipped to radians for the graphs of those periodic functions. And then how we solve for this alpha, we're just going to, on both sides, do inverse tangent. Okay. And because alpha is in quadrant 1, because it's less than 90 degrees, we don't have to worry about these not canceling each other out. They will always cancel each other out. All right, so then inverse tangent of 15 over 20 is what you're typing in your calculator. Oops, and I didn't have mine in the right mode like I told you to do. Let me try that again. And I'm going to round it to the nearest tenth, 36.9 degrees. You should get when you do the inverse tangent. Okay, so if it was sine we wanted to cancel out, we do inverse sine. If it was cosine, we do inverse cosine. You don't have buttons for inverse cosecant, inverse secant, and inverse cotangent on here, but on the last slide today I'll show you how you can type those in if you need to. But I would stick with sine, cosine, and tangent, especially with these. Okay, then all I have to do is times 2, because there are 2 alphas to get a theta in this picture. And I get 73.7 degrees when I use the exact value from my calculator. Okay. Any questions on that? Okay. Last slide then is just showing you how to type certain things in your calculator. Don't worry too much about the top here. You can just kind of write this stuff down and write how you're typing it in. Ones like this guy are pretty straightforward. If you have an inverse sine, an inverse cosine, an inverse tangent, we have the buttons for those. Just make sure if you're doing it in Math Excel especially, you're looking at what kind of answer it wants. Okay, so like these two on the left, we want answers in radians. If you want an answer in radians, I would recommend putting your calculator in radians. This is a test that we're going to do next week, where, well, end of this week a little bit, where you're going to have to go back and forth. You're going to have to kind of think ahead. Do I want a radian for this? Do I want a degree for this? And kind of alternate the mode as necessary. All right, so if I put my calculator in radian mode, inverse sine of 0.75, I get, I'll just round to 2 decimal places, 0.85. I'll show you how to take those other ones in. Yes. I've solved. And I know where it is because I put away this one. Okay. Let's say I want an inverse. Let's go over to this one actually, because cotangent's special. Inverse cosecant or inverse secant, these are going to work the same way. This problem I want an answer in degrees, so I'm going to go ahead and flip my mode real quick. Okay, when we type this in, you have to know what its reciprocal function is. The reciprocal of cosecant is sine, so I'm going to use inverse sine. And this number, 3.5, is the reciprocal of the sine value. And when we say reciprocal, if you guys remember the formulas that we did before, it's just 1 over that number. So if it's a fraction, you can just flip it. But in general, 1 over that number calculates the reciprocal. And that's how you type it in your calculator. Okay, so cosecant or secant would work this same way. All right, so inverse sine of 1 over 3.5, I get in degrees 16.6 degrees. Okay. If you forget to flip the number, it'll give you an error, so you'll know you missed something. All right, inverse cotangent. Now, let's go back to our radians. Okay, so radian mode. And I'm going to type in inverse tangent. Nope, maybe. There it goes. Inverse tangent. So that's its reciprocal. And the reciprocal of the number. So the reciprocal of the function and the reciprocal of the number. That's how we're doing this. So inverse tangent of 1 over 2.3 in radians is about 0.41. Let's look at the next one. Okay, the last one's in degrees, mode, degree. I'm going to type in the inverse tangent of 1 over negative 3.4. Inverse tangent, maybe, 1 over negative 3.4. I get negative 16.4 degrees. Okay, put a little star by this one. Okay, this is the only one that doesn't work perfectly in our calculator. If it's a cotangent of a negative number is the issue here. Okay, the last one was cotangent of a positive number. There's no problem with that. If it's a cotangent of a negative number, if you guys remember where the functions were defined for, tangent was defined in 1 and 4. Cotangent, this is the only case where the two functions are, reciprocal functions are in different quadrants. Cotangent is in 1 and 2. So if I'm evaluating an inverse cotangent, I need an answer in quadrant 1 or in quadrant 2. What quadrant is this answer in? 4. And it's spitting out an answer in quadrant 4 because that's where inverse tangent is defined in. Okay, so again, only if it's cotangent, because those are the only ones that are weird, and only if it's a negative number. Here's how we adjust our answer. All you have to do is take this guy and move him from quadrant 4 to quadrant 2, which those are on opposite sides of your quadrants, right? Down here and up here. It's just a 180-degree rotation. So if your degrees, you're going to add 180. So negative 16.4 plus 180 is going to give me 163.6. If it's radians, what are you going to add? What's equivalent to 180? You add pi instead. Okay, so you can even put in your notes or pi there. Okay, again, only if it's cotangent, only if it's a negative number. Everything else in your calculator will work perfectly.
Like one or both, like only cotangent and negative?
Yep. Cotangent and a positive will work fine. Negative numbers for other functions will work fine. It's the only weird case. Okay, and that's it. That's the only stuff we didn't get to on Friday. So you guys have a little more than a half hour to work, okay? I'll do cell phone lotto now, so you can have those back if you want to. Let's see. When's our 5-6 math Excel due? Tonight? Tomorrow night? Tonight? Oh, tomorrow night. I give you an extra day. All right. It has a lot of questions, but there are a lot of quick little ones. Remember, if you have your unit circle out, it's going to make things a little faster, and then you can check it even in the calculator with this stuff that we just talked about too. Okay. All right. Go ahead and get started. Let me know if you have questions on anything.